Good day guys! Here I am again, Mr. Brian Bulactin at your service. In my first video, you learned about polynomial expressions. And learning polynomial expression would help you to understand more polynomial function. So what is a polynomial function? Now let's take a look at this. A polynomial function is actually a function of the form p of x is equal to a sub n, x to the exponent of n, plus a sub n minus 1, x to the exponent of n minus 1, plus a sub n minus 2, x to the exponent of n minus 2, plus so on, plus a sub 1, x, plus a sub 0, where your a sub n shouldn't be equal to 0, where n is a non-negative integer. A sub 0, a sub 1, and so on until a sub n are real numbers called coefficients. Your a sub n, x to the exponent of n, is the leading term. A sub n is known as the leading coefficient, and a sub 0 is the constant term. So this is the number without a variable. The highest power of the variable p of x is known as its degree. To name a function, you can actually use any letter in the English alphabet, capital or small. But for polynomial function, we'll be using p. So you have p of x, or you can use y. In the standard form of a polynomial function, we have p of x, function of x. It is x here because the variables found on the right side of the equation are x. That means whatever letter is found on the right side of the equation, that would be also the letter that you're going to place inside the parentheses. Now let's have this expression, 3x squared plus 5x minus 1. Is it a polynomial function? What do you think? The answer is not. It's not a polynomial function. Instead, you call it a polynomial. So this is a polynomial expression. But the moment you'll see p of x equals 3x squared plus 5x minus 1, or y equals 3x squared plus 5x minus 1, you can already call it a polynomial function. Therefore, in a polynomial expression, there is only one variable involved, while in a polynomial function, there are two variables involved, your x and your y. There are important terms in the definition of polynomial function, and these are degree, leading term, leading coefficient, and constant term. So, again, what is a degree? A degree is the highest exponent of your variable x. The leading term, it is the term with the highest exponent. And if you will say leading coefficient, it is the numerical coefficient of the leading term. And of course, the constant term is the number. It is the constant, the number that has no variable beside it. Now let's have example number 1. Y equals 5x squared plus 3x minus 10. What is the degree? So what is the highest exponent of our variable x? It is 2. So that is the degree of the polynomial. For the leading term, you're going to get the term that has the highest exponent, and that is 5x squared. You're going to get the whole thing, the entire term. And from your leading term, you'll get the leading coefficient. That is the numerical coefficient of your leading term. And in this case, 5 is your leading coefficient. And what is the constant in the given? The number without a variable beside it is negative 10. Let's have another example. Y is equal to 7x cubed plus 6x to the exponent of 5 minus 10. You have noticed that the terms are not arranged in descending order of powers, right? So in this case, the first step to do is to rewrite the given polynomial function with exponents in descending order. So this will become y is equal to 6x to the exponent of 5 plus 7x cubed minus 10. And this is what we call the standard form. This is the standard form of your polynomial function when the terms are arranged in descending order of powers. After doing that, it would be easier to identify the degree, leading term, leading coefficient, as well as the constant term. What is the degree in this example? The degree is 5, since it is the highest exponent. The leading term is the term with the highest exponent, so that is 6x to the exponent of 5. And from your leading term, you get the numerical coefficient, the number beside your x, and that is 6. So that is your leading coefficient. And what is our constant term? The number without a variable beside it. That is negative 10. There are various types of polynomial functions based on the degree of the polynomial. Here are the common types of polynomial function. The first one is the zero polynomial function. So the zero polynomial function is the function with degree 0. The zero polynomial function takes the form p of x is equal to ax to the exponent of 0 is equal to a. Ax to the exponent of 0 becomes a. It is because any quantity that is raised to 0 is equal to 1. That means this can be expressed as a times 1. So your a times 1 is equal to a. So let me give you an example for this. Y is equal to 7. So this is an example of a zero polynomial function. Y is equal to 7 is an example of a zero polynomial function, and it can be written also in the form p of x is equal to 7. So what is the degree in this example? So you don't see a variable beside it. That means there is actually a variable but raised to the exponent of 0. Therefore, your degree here is 0. What is our leading term? We don't have a leading term here because a leading term is composed of a number and a variable, and we don't have that here. That is why you're going to put here none. What is our leading coefficient? So if we don't have a leading term, obviously we don't have also a leading coefficient. So your answer would be none also. And for the constant term, what is the constant there? If you'll say constant, it is the number without a variable beside it. And in this example, it is 7. Now let's have example letter B. P of x is equal to 10. Or you can have y is equal to 10. What is the degree? The degree here is, again, 0. Now let's move on to the leading term. Please allow me to use LT for leading term. And our leading term here is none. We don't have that in the given. Then, since we don't have a leading term, we don't have also a leading coefficient. And our constant term is, of course, 10. So I guess zero polynomial function is easy to understand. Now let's move on to another type of polynomial function, and that is linear polynomial function. So a linear polynomial function takes the form p of x is equal to ax to the exponent of 1 plus b. The highest exponent of x is 1. Therefore, linear polynomial function is a function of degree 1. Now, let's have examples for linear polynomial function. y is equal to 3x plus 2. So what is our degree? What is the highest exponent of x? The highest exponent of x here is 1. So our leading term is 3x. So it is the term with the exponent, with the highest exponent. So it's 3x. And our leading coefficient is the numerical coefficient of our leading term. Therefore, that is 3. And our constant term is 2. Now let's move on to our second example. We have y is equal to 5x minus 18. In this example, obviously the degree is 1 because that is the highest exponent of your x. The leading term is 5x. Our leading coefficient is 5. So this is our leading coefficient taken from the leading term. And our constant term is negative 18. Now let's move on to the third common type of polynomial function, and that is quadratic polynomial function, or it is a polynomial function of degree 2. So it takes the form p of x is equal to ax squared plus bx plus c. So let me give you an example for this. Y is equal to 7x squared minus 10x plus 5. Now let's identify the degree. The highest exponent of your x is 2. So that is your degree. The leading term is the term with the highest exponent, and that is 7x squared. Your leading coefficient is the numerical coefficient of your leading term, and that is 7. And your constant term is 5. So I guess identifying the degree, leading coefficient, leading term, as well as the constant term is so easy. So let's have another example before we proceed to another common type of polynomial function. So for letter B, what if you will be given y is equal to 10x plus 3x squared minus 4. You have noticed that the given is not in standard form. So the first step is you rewrite it into standard form. And this will become y is equal to 3x squared plus 10x minus 4. After that, you identify the degree. In this example, the degree is, of course, 2. The leading term is 3x squared. The leading coefficient is 3. And the constant term is negative 4. So there you have it, guys, for quadratic polynomial function. Now here comes in the fourth common type of polynomial function, and that is cubic polynomial function, a function of degree 3. It takes the form p of x is equal to ax cubed plus bx squared plus cx plus d. Let me give you an example of a cubic polynomial function. Y is equal to 3x cubed plus 7x squared plus 4x minus 1. So obviously, the degree in this example is 3. Our leading term is 3x cubed. Our leading coefficient is 3, and our constant term is negative 1. And let's move on to another example. Y is equal to 14x squared plus 7x cubed minus 11. You have noticed that the given is not in standard form because the exponents are not arranged in descending order of powers. So that's the first step to do. This will become y is equal to, you're going to rewrite it into standard form. Y is equal to 7x cubed plus 14x squared minus 11. You have noticed that in this example there is a missing term. How can you tell that there is a missing term? Look at the exponents. If there is or are exponents skipped, then there are missing terms. Like in this case, we have exponent of 3, exponent of 2, then it immediately jumps into exponent of 0. So there is a missing term here. Your linear term is actually missing, or the exponent of 1 is missing. But even if there are missing terms, still you can identify the degree. And that is, of course, 3. Your leading term is the term with the highest exponent, and that is 7x cubed. Your leading coefficient is the numerical coefficient of your leading term, and that is 7. And your constant term is negative 11. Now let's move on to the fifth common type of polynomial function, and that is quartic polynomial function, or a function of degree 4. It takes the form p of x is equal to ax to the exponent of 4 plus bx cubed plus cx squared plus dx plus e. So let me give you an example for this. P of x is equal to 30x to the exponent of 4 plus 11. So you have noticed that we have missing terms in this example because we don't see exponent 3, exponent 2, exponent 1, right? From exponent 4, we go immediately to exponent 0 for x. But again, it's not a problem. That wouldn't hinder you to identify your degree, leading term, leading coefficient, as well as constant term. Now let's start with identifying the degree. For this example, of course, our degree is 4, since this is a quartic polynomial function. The leading term is 30x to the exponent of 4. The leading coefficient is 30, and our constant term is the term without a variable, 11. So that is for our first example of quartic polynomial function. Now let me give you another example for quartic. Y is equal to 7x cubed plus 10x to the exponent of 4 plus 2x plus 1. Obviously, the given is not in standard form. So just like what I said, you have to rewrite first the given into standard form. So this will become y is equal to the term with highest exponent, that would be 10x to the exponent of 4, followed by 7x cubed plus 2x plus 1. After rewriting it in the standard form, identify the degree. In this example, the degree is of course 4. The leading term is 10x to the exponent of 4. Your leading coefficient is 10, that is the numerical coefficient of your leading term, and our constant term is 1. And now let's move on to the last common type of polynomial function, and that is the quintic polynomial function, or a function of degree 5. It takes the form p of x is equal to ax to the exponent of 5 plus bx to the exponent of 4 plus cx cubed plus dx squared plus ex plus f. Let me give you an example for this. Y is equal to 3x to the exponent of 5 minus 4x to the exponent of 4 plus 3x cubed plus x squared minus 28x plus 1. So this is an example of a quintic polynomial function where all the terms are present. So after this, you can identify immediately our degree. And of course, that is 5. Now let's move on to the leading term. The leading term is the term with the highest exponent, and that is 3x to the exponent of 5. From the leading term, you can get the leading coefficient. It is actually the numerical coefficient of your leading term, and that is 3. And for your constant term, the term without a variable, that is positive 1. Now let's move on to the second example. Y is equal to 4x cubed plus 7x squared plus 6x to the exponent of 5 plus 7. Again, the terms are not arranged in descending order of powers. Therefore, it is not in standard form. So, rewrite it first to standard form. This will become y is equal to 6x to the exponent of 5 plus 4x cubed plus 7x squared plus 7. Then, you identify the degree right away. The degree is 5. The leading term is, of course, 6x to the exponent of 5. Your leading coefficient is 6, and your constant term is 7. So there you have it, guys, the different types of polynomial functions based on the degree of the polynomial. So they're actually the common types. There are still a lot of functions, polynomial functions out there. But if in case you will be given polynomial functions with exponents higher than 10, you can actually name the polynomial function using its degree. You can call it, or you can name it, n degree polynomial function. Like for example, if you will be given p of x is equal to 20x to the exponent of 100 plus 1. The exponent is 100, so you can call the polynomial function 100 degree polynomial function. There you have it, guys. Thank you so much for bearing with me. If you have questions, clarifications about the topic today, and if you have comments and suggestions about the videos, feel free to message me via Messenger. My FB account is Bryan'sLoves. Till next time, thank you.